So translation is taking a piece of mRNA, a ribosome, and some tRNAs to produce an amino acid chain. And there's also some variation between prokaryotes and eukaryotes translation. And we have a series of different enzymes that involve in this process. And it also consists of initiation, elongation, and termination stages. So let's take a look at the initiation stage first. So this is the table I summarized for you. So it differentiates between prokaryotes and eukaryotes. So for the prokaryotes initiation stage, the initiation factor 1 and the initiation factor 3, they bind to the 30S subunits of the ribosome. And then the mRNA bind to the 30S subunits of the ribosome. And the mRNA contains a specific sequence called Xuan sequence, which is complementary to the 16S rRNA of the ribosome. And then the initiation factor 2, it binds to GTP to promote the binding of tRNA formomethionine to start codon in a P site. So the initiator for prokaryotes is tRNA formomethionine, which is key point to remember. So then the initiation factor 1 and 3, they are released. And then the 50S subunits associates to form a 70S complex. Okay, that's for the prokaryotes. So the eukaryotes, they have eukaryotes initiation factor 4, which bind to the 5' in the mRNA, and the initiator for eukaryotes is tRNA methionine, which is different from the prokaryotes. And then the entire assembly, they just scan for the start codon. They just move on. And once they found the AUG start codon, the 60S subunits bind to it and form a 80S initiation complex, which end the initiation stage. Then the elongation stage. Notice there are 3 sites here: A site, P site, and E site. So you always from the right to left. So the A site stands for amino acyl site, and P is peptidal site, and E is the acid site. And we have a mRNA strand here. Those represents the ribosome. 50S subunits is green and 30S subunits is yellow. And this is the tRNA and attached by some amino acid. Okay, so a charged tRNA binds to an A site and facilitated by a protein called EFTU, which hydrolyzes GTP. And the peptidal transferase catalyzes bond between polypeptide and amino acid at the A site, and the polypeptide is transferred. So it comes another protein called EFG. It helps ribosome translocate one codon to the right by hydrolyzing one more GTP. And then an uncharged tRNA is released from the E site. And that's the end of the elongation stage. So finally, the termination stage. So the termination stage is recognized by a stop codon, and the stop codon is recognized by some specific enzymes, and is different in bacteria and eukaryotes. So in bacteria, 3 types of release factor. Release factor 1, it recognizes stop codon sequence UAA and UAG. The release factor 2 recognizes stop codon UAA and UGA. And release factor 3, it binds to GTP to facilitate termination. Okay, so for the eukaryotes release factor 1, it binds to a stop codon UAA and UAG and UGA. And the eukaryotes release factor 3, it has analogies to the release factor 3, so they work in the same way. Okay.